In this video lesson, let's learn about mean and standard deviation for data. Okay, and we have one problem which says the data represents the number of milligrams of a substance in a patient's blood found on consecutive doctor visits. Find the mean and standard deviation of the data. Okay, now the standard deviation is a way of measuring what the spread of the data is like. Okay, so if the standard deviation, which is denoted by sigma, is a small value, okay, if this is small, then the data is clustered around the central value or clustered around the mean, and if sigma is large, then the data is very spread out. Okay, so this means clustered around the center, and this means it's spread out. Okay, now to find the standard deviation, we need to follow a few steps. First, find the mean of the data. Okay, so find the mean of the data. We all know how to do that. Second, what we are going to do is find the difference between each data value and the mean. Okay, so that's the next step. Find the difference between each data value and mean. Okay, now each of these differences needs to be squared. So square each difference that we found in step 2. Okay, next what we are going to do is we are going to find the mean of these squared differences. Okay, and the mean of these squared differences is something called the variance, which is denoted by sigma squared. Okay, and the standard deviation, or sigma, equals the square root of the variance. Okay, so what we need to do is take the square root of the variance. Okay, these are the steps involved in finding the standard deviation. So what we're going to do first is take this data and find the mean. So the data says 14, 13, 16, 9, 3, 7, 11, 12, 11 and 4. Okay, and I know that the mean of a set of data is the sum of all the data values divided by the number of data values. So mean equals sum of data values divided by number of values. Okay, in this case, if I add up all of these, I'm going to get 100. Okay, I've already added these up, and I'm not going to show you the addition because we know how to add, right? And the number of data values is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10. Okay, dividing 100 by 10, I get the value of the mean as 10. Okay, that's my first answer because the problem asked me to find the mean first, right? So that's the mean. Once I know the mean, I can find the difference between each of these data values and the mean. That's the next step. Okay, to do that, let me insert a table. Okay, so I have this table which gives me all the data values listed. Okay, and I need to find x minus mean. So what I'm trying to do, if each data value is x, then I'm finding the difference between the data value and the mean by subtracting the mean from this data value. Remember that the mean is 10, so I need to subtract 10 from each of these values. 14 minus 10 is 4, 13 minus 10 is 3, 16 minus 10 is 6, 9 minus 10 is negative 1, 3 minus 10 is negative 7, 7 minus 10 is negative 3, 11 minus 10 is 1, 12 minus 10 is 2, 11 minus 10 is 1, and 4 minus 10 is negative 6. Okay, so that gives me all of the differences between each data value and mean. Okay, now what I'm going to do is I'm going to square all of these differences in the next row, right? So let's square all of them. 4 squared is 16. Okay, 3 squared is 9. 6 squared is 36. Negative 1 squared is 1. Negative 7 squared is 49. Negative 3 squared is 9. Okay, 1 squared is 1. 2 squared is 4. 1 squared is 1. And negative 6 squared is 36. Okay, now remember that these are all pretty easy squares because these are small numbers. In case the numbers are larger, you might want to calculate them separately on a piece of paper or use a calculator, right? These were simple, so I've done them mentally in my head. Very easy to do. Okay, now this is the square of the differences, or this row represents the square of the differences between each data value and the mean. Okay, so I've already done the first step, the second step, and the third step. Now what I'm going to do is find the variance, which is the mean of the squared differences. Okay, so the mean of the squared differences means the mean of all of these values which are in the third row. So all I need to do is add all of them up and divide them by the number of values, which is still 10. Okay, now the sum of all these values, something that I've already computed, okay, and that comes to 162 if I add all these numbers up, right? So x minus mean whole squared, okay, the mean of x minus mean whole squared, right? So the mean of all these values equals 162 over 10, which means 16.2, right? And this is a value which is sigma square of the variance. Okay, now I'm going to use the variance to find the standard deviation. I know that the standard deviation SD, which is denoted as sigma, equals the square root of the variance, sigma squared. So that equals square root of 16.2, which equals, okay, which approximately equals 4.025. Okay, that's the answer. That's the standard deviation that we were looking for. Okay, so quick recap of what we've done here, and the key point to remember. First, if you have a set of data and you need to find the standard deviation, find the mean of the data first, right? I know mean is the sum of the data values divided by the number of values. Okay, next, find the difference between each data value and the mean, okay, and write all of those differences down. Square each of these differences, okay, and then find the mean of these squared differences. This mean of these squared differences, right, this mean is called the variance and is denoted as sigma squared. Okay, the standard deviation, or sigma, is the square root of the variance. Okay, so now what I'm going to do is, once I've found the mean of the squared differences, take the square root of that mean, and what you get is the standard deviation.